Hi, good morning. My name's Duncan Simpson. I am the chair of the Education, Training and Competence group within the Switch Forum. If you tuned in today in order to watch a webinar on fire suppression that's going to be delivered by Helios Fire Systems, then you're in the right place. And if you'll allow me, I'm going to do a little brief introduction. I know many of you know Switch and Switch Forum, but it's worth reminding you of who we are and what we're here for. We're a charity organization. We were set up a number of years ago. The idea was to provide a focus and a forum that would engage with the industry and experts and others on two key areas. One being education, training, and competence, which is important to all of us and all the businesses that operate to make sure that our workforce is supported, trained, has careers, sees the industry as an exciting sector to move into the future. And the other area, which is no less important and obviously part of that education, training, and competence is health and safety. Our industry over a number of years has had a relatively poor record in this area, mainly down to the circumstances we operate in. Lots of heavy vehicles, lots of pedestrian vehicular interaction, lots of equipment, constantly moving platform that we're on, either literally or in the legislative world, which is causing us to keep on redeveloping sites, managing materials in different ways, and interaction with the general public and commercial businesses. So the Switch Forum's here to provide that open platform for discussion. We have a website. If you Google Switch Forum rather than Switch, which will take you to an interesting PlayStation, but Switch Forum, which will take you to a more interesting place on education, training, competence, health and safety. You'll find a number of helpful documents, assets there to help you with your day-to-day business. You'll find recordings of these webinars, and we would encourage either your organization or you as an individual to join. It's free to join, encourage others to join. And as part of that focus, one of the benefits we get is the opportunity to engage with expert speakers. I need to say thank you to Ewan from SLR Consulting. He supports and helps us in an active role within the Health and Safety Committee on Switch Forum. And he proposed to us that we have a great speaker today in the form of Garry Adey. He's from Helios Fire Systems. And I think we're all aware of the issues that we face from the dangers of fire in the sector, and that's become even more relevant today. So hopefully not stealing too much of Garry's introductory slides, some background to fire. Recent figures from the ESA would have told us that back in 2016, 2017, we were experiencing, we think, about 334 fires across the UK in the 1 year. And in 2019, 2020, bearing in mind that's got difficulties in terms of gathering that data because of COVID, we think that's up to 670 fires. And obviously, fire creates enormous dangers for human life, accident, injury, death. It impacts your plant and equipment, your day-to-day operation. It impacts neighboring sites, housing, people, and it impacts the environment in terms of emissions to air, emissions to the ground, and emissions to watercourses. And let alone all of that, but if you've been in the horrific situation of experiencing a fire, you then know the on-costs in terms of the impact on staff morale, the impact on the business, the impact on costs, the impact on finding someone who's willing to insure you on a basis going forward. And in that background, knowing that fire is something that is extremely difficult to control once it gets a grip, hopefully Garry today and Helios Fire Systems are going to give us a really interesting presentation and insight into what their experience, their knowledge, and their technology can do in helping suppress fire, stop fires in the first instance, and what they can do in terms of making you aware of where the dangers are and how to manage those dangers. So without further ado, I am going to hand you over to Garry and switch off my camera and switch off my microphone. And Garry, I'll let you have the floor if that's okay. And I see a lovely image of Gordon from Lomac, which is always nice to see on a Thursday morning. But if we can all switch off our cameras, I think that'll just let the bandwidth play. At the end of Garry's first part of the presentation, he's going to open up for Q&A. If you have any questions as you go along, you can greatly help me by typing questions into the Q&A. If you have a really overwhelming desire to get right in there and ask Garry a question straight away on something that's triggered, please do it. But he's got a lot to go through in a short space of time. And I can field some of those questions for you. But if you really want to interrupt, stick your hand up, your electronic hand, and we'll try and cater for that during the presentation. But there's two parts to this. Once the first bit's over, we'll pause for some Q&A, then we'll start again on a more specific piece of kit that Garry has and wants to talk to you about, and then I'll give you as long as possible for Q&A at the end of the presentation. So without further ado, can I introduce you to Garry Adey from Helios Fire Systems, who's going to speak to us from sunny Manchester today, and he looks very calm considering the technology he's going to put in place now, which worked brilliantly before this moment, but I probably stymied him by that. So I'll hand over to you, Garry, and thanks again.
No problem. Thank you much. So good morning, all. Just a quick introduction. I'm Garry Adey. I'm the Managing Director and founder of Helios Fire Systems. A quick introduction to the business. We're the market leader in automatic targeted fire suppression systems for the waste industry. I'm going to split the presentation into two of our very high level pieces of equipment that we're currently installing across Scotland and across the whole of the UK, into two sections where we're seeing huge amounts of increase of fires or potential risk of fires. First being obviously the ATFS automatic targeted fire suppression system for waste hauls, and then secondly we're going to look at AMFE, which is our automatic miniature fire extinguishers for in control electronic control panel protection systems. So we'll touch base on those as the guys have said there. We'll have a break in the middle for questions after ATFS, and then we'll roll straight onto AMFE and then take any other questions from there onwards. So I'm just going to share the first part of this presentation now, which is going to be on ATFS. There's going to be some videos, as the guys have said there. If you want to drop on and ask any questions as we're going through them, please drop those through the Q&A, or if you want to talk through it, I'm quite happy to stop the webinar and obviously talk about any of the details that might be pressing for you, and talk about that particular point at that point in time. So I'll share my screen with you now. Okay. So we can see we've got quite a dramatic screen here. Obviously, this is the impact that none of us want to be seeing in any of our industry or any of our businesses. And this image was sent to me by a client when we first started delivering solutions for early warning fire protection, and we're very, very closely connected to the fire brigade here in Manchester through family, as well as also with our professional connections. And for me, this is an image which we particularly don't want to be seeing for the waste industry as a whole. And it was one of the forefront images that decided us to start marketing a targeted fire suppression system. So I'm going to start the presentation now and then roll into the first video, so you can get an understanding of what ATFS is. As per the slide there, ATFS stands for Automatic Targeted Fire Suppression, and you'll see exactly how that works now.
Gary, is there supposed to be any voiceover for this? Because there's no volume coming through, mate.
Yeah, I don't know why the volume's not coming through for some reason. I don't know if it's set up on Teams.
Okay, mate. The pictures are clear, but there's just no audio. That's all.
Yeah, I don't know why the audio is not coming through. The bandwidth is running very, very slowly. Can you all hear me now?
Yeah, I've got you, Gary.
Okay, cool. So basically, what we've seen there is the automatic targeted fire suppression system at work. But basically, what the system's doing is it's a very highly intelligent camera system that is analysing 5mm sections of ground and looking at temperature changes in the waste. So when the system is actually going off, it's going off way before a fire. In most instances where we run this system, we very rarely actually have a flame to actually deal with. So I'll go into the main part. Obviously, this is going to be available for you all to download through the forum, and you'll be able to see that video, or I can transfer it out to people or whatever. So I'm just going to go into some stats, just a bit of a taster of what the system is and how it works. We'll go into some more details on how it actually targets and how it actually deals with the fire as we go through the presentation. But some stats, these are up-to-date stats. We work very closely with the insurers here across the whole of the UK. We have to produce stats on a quarterly basis on our systems because of how prevalent our systems are in the marketplace, and we have to prove that our systems are working in the industry. So off the back of that, we're exposed to a lot of data from the insurance industry, which are quite damning in regards to the damage that fires can have on a business going forward. So some stats for you. Approximately 25 incidents per week are requiring fire brigade attendance across the UK. Average lost operational time for those incidents is probably about 10 days. And obviously, depending on how big the fire is, obviously, if it's a large fire that's spread and they've got building damage, that could be even longer. But on average, the insurance is saying for business continuity claims, they're getting roughly 10 days of claims thereafter any fire incident. Outside of that, we're having approximately 5 serious incidents per week that require multi-brigade attendance. That means, let's say there was here in Manchester, and then we had to have Salford or Bolton or Bury fire brigades coming in, then they would all be brought into one of these fires. And obviously these are huge case scenarios where the impacts on the business are huge, where they may have 10 or 15 fire engines in attendance. 82% of these incidents results in that business ceasing to trade. So how can these clients not become one of these stats? Obviously, they don't want to be going out of business. They've got people to employ. They've got a business to run. They've got contracts to fulfill. Well, for us, it's basically installing the Helios ATFS system. 100% of the clients who have installed our system have had little or no business interruption after any system activation, and have continued to trade with no adverse financial impact. We're going to go into some stats now actually on the system and how well it performs, and that even goes through to the amount of insurance claims and business downtime in regards to business continuity. So, stats. I'm going to run through these line by line, and you can see exactly what impact our systems are having on the insurance industry as well as the clients themselves. So we've got a stat here that goes back 4 years, back to 2019. We have got further data than that going back to 2014 when we first developed the system. But we can see here we've grown quite exponentially over the last 2 years. We had 22 systems installed back in 2019. We've now got 58. I know that FPP doesn't really fall Scotland at the moment, but it will do through SEPA, but there will be more and more regulations brought into place. Our systems are compliant with FPP down here. As you can see there, the majority of installs we've got have all FPP approval. We've got 2 systems that haven't got FPP, and they're both up in Scotland. One for Hamilton Waste and one for Envar at Glasgow, because obviously they don't require the FPP approval. Going into how the system is detecting, we have 2 levels of detection warnings on the system, so we don't actually have a fire breakout. So our first alarm warning is a pre-alarm set at 90 degrees. So that's any temperature within a waste pile or bale pile or anywhere inside that building that hits 90 degrees at 50 millimeters square, we will get a pre-alarm, and that pre-alarm will warn us prior to actually any fire breakout or thermal runaway. So you can see here, going back from the bottom, 2019, 110 to where we are today now, 310 pre-alarm activations per month. So before this technology, that could have been 310 fires. At this stage now, pre-alarm, we're allowing the customer to actually deal with the hotspot at source, whether extracting the hotspot out or actually dealing with it with hoses or whatever they want to do, or going with a loading shovel, extracting it, putting it in quarantine and dealing with it from there. Should we get thermal runaway, let's say we have a lithium-ion battery that's been compromised, that has triggered one of those 310 pre-alarms last month, and it achieves 150 degrees at 50 millimeters by 50 millimeters, you can see the activations we're actually getting here now. So we can see, going back to 2019, we're having 25 activations of 110 pre-alarms. Prior to that, 36, 22, 4. So you're going to say to me now, well, the fires are getting less and less. Yeah, they are getting less and less, because we're actually activating here at the pre-alarm and giving the client the time to deal with the hotspot before it becomes a fire. So here now we're actually getting 4 activation system. That's actually 4 hard activations where the system is going full extinguish mode, targeting, and then extinguishing the fire or hotspot. In most cases, as I said before, you don't actually have a flame. You will have a hotspot that the camera system can see, and the wetting agent that we use inside the extinguishing media allows it to actually penetrate the pile and actually deal with the fire. In most cases, we're having most cases clients are calling the fire brigade out. So we have 10, 5, 4, and 6 last year. So even though we only had 4 brigade call outs based on 190 before, or 22 system activations here, we had 6 in 2022 based on 4. So one of these might have been linked to, or a couple of them might have been linked to a monitoring system that called the fire brigade out. But a lot of clients are very, very open with us, and they give us that information. so we can put this data together. Activation time. So this is really important in regards to business continuity. We're down to 3 minutes per activation. So that's actually the Canon system going off and dealing with a hotspot. So that's on average 3 minutes per activation of these 4 systems that have actually gone off. They've gone off for about 3 minutes apiece. When you look at the volume of water that we're putting out at 1,500 litres per minute per cannon, you're looking at a maximum of 5,500 litres of water maximum on the floor. When you look at sprinklers or deluge systems, you're looking at tens of thousands of litres. So we can actually deal with a fire at source, targeted, with minimal impact to the business once we've had the activation. Forget this brigade call out. There's 2 slides in there for some reason. I don't know why that one's gone in. So post-activation downtime. So this is going back to business continuity. So business continuity, we're down for about 3 hours currently at the moment, back to 6 in 2019. So this is the time scale from actually the system working automatically in detecting a hotspot, a pre-alarm going through to a full alarm fire situation where we're extinguishing, the cleanup afterwards, and then getting back to work is roughly about 3 hours. So again, we're minimizing the time that the site has to be shut down. We're minimizing the losses in revenue to the site once an incident actually happened. False alarms, which is very, very important. We're getting 0 false alarms now. The technology has moved on massively in the past 2 or 3 years. Again, when we go further through these slides, you'll see how we've developed a system to understand what's a loading shovel. We understand what is a bin wagon that's coming in, a scrap handler, a waste handler, whatever it may be. We can program the system to understand. So out of all these systems, 58 systems in the last 2 years, we've had no false alarms whatsoever. Again, probably the most important one, insurance claims, obviously knocking on from the incidents that we're having here. Full activations, they aren't being reflected here in insurance claims to the insurer. We had 2 in 2019, which were 2 small business continuity claims, which were probably in the region of around about 30,000, I think, in total. So from the insurer's point of view, the assets that we're protecting now is well over 300 million pounds of assets. What the premiums are on those, I have no idea, but it's going to be in the probably 10 million plus in premiums, if not more, with no payouts on insurance claims. So I hope you can see there, obviously, how well the system's performing, how well we're actually doing the installs, and how the system's actually detecting. So we'll go into more of that now on how the system actually works.
Gary, I've got a question from Simon Norris, and he's asking, how does the camera distinguish between a hotspot and a vehicle exhaust?
Okay, so the system, once it's installed, uses artificial intelligence and deep learning. We spend 2 weeks after the initial installation to actually analyze every single heat source inside that building, and we log each of those temperatures inside the database, so it knows. So if we know we've got a Liebherr 960, whatever it might be, or a JCB 130, whatever they're called, the camera can actually be programmed to understand that that's a machine, and we set it at an X pixel by Y pixel size for the heat source for that machine, and then a temperature that it's running at as an operating temperature. As a safeguard for the system, and we do know that we do have plant fires, so mobile plant fires, we have machinery fires. The system is also programmed and intelligent enough to know that Liebherr that is supposed to be 960 by 1020 pixels at a running temperature of 230 degrees, let's say. If, for whatever reason, the operator of that vehicle then decides that he's going on his break and he leaves it by the waste pile, and he hasn't been cleaning off the rear axle, or there's been a buildup of waste around the engine bay area, and some material catches fire, the camera system will see it, and it will see the temperature rise. It will then say this is a Liebherr 960, and it'll say, well, it shouldn't be at that temperature. And once we then start seeing that temperature hit a temperature of around about 350 degrees, the Canon system will then go off on that machine. So it's very intelligent that it understands every single piece of equipment coming in. And you might turn around and say, well, we have probably 700 different wagons coming into our building. Well, our experience with wagons are they all run roughly the same temperature. They're all roughly the same size. They all have the same rough size of brake discs. They all have the similar exhaust stacks. And they're the big parts that we need to be very, very careful with, that we don't actually go off on those machines. So if we've got a DAF or a Scania or a MAN or whatever it may be, a Volvo, they're all around the same sort of heat signature that we can dial into the camera system, for the camera system to be able to understand exactly what that piece of equipment is, or that hotspot. Hope that's answered your question. Again, we'll go into more of this as we go through the presentation now. So what sets ATFS apart from other technologies? So we're showing a graph here now of the potential for risk of damage to the building or to the client from a business continuity point of view, or to actually potentially losing the building here. So what we're actually going to show here across this screen as we move on now is the types of technologies that are in the marketplace, where they fit in regards to the detection time and the potential of the damage using that potential technology. So first one, well, I'm going to promote my product first because we're the earliest. So ATFS targeted fire suppression with PyroSmart early warning thermographics. We are here. We are at the very, very bottom end of this curve of damage, and at the earliest timeline of a development of a fire. We don't need smoke. We don't need vapor. We don't need flames to activate. We just need a hotspot. We can trigger from one degree above background temperature as a pre-alarm or a full alarm. Obviously, we're not going to do that. But thermographics are the most advanced way of detecting deep-seated fires within waste piles or baled storage areas. So that's where we are. We have thermographics. The next one, come on. The next one along is aspiration systems. So again, they're going to be able to detect the smoke at a later stage than where we are. At this stage, we've got more of a risk of thermal runaway. We've got a potential risk of a fire breach to the surface, and once it goes across the surface, we've then lost the waste pile. Next is superheated smoke through CCTV smoke detection. So we do CCTV smoke detection cameras for customers that can't afford PyroSmart, and yes, they are good. But you will always have a flame. You will always have a lot of superheated smoke, which can then also cause issues for the detection system to actually see what's going on, especially if the room fills with smoke rapidly before we get any massive thermal runaway. But again, you can see here we're getting lots of potential damage to the site and the building, and the curve is starting to move very, very rapidly. Next one is IR3 flame detection. So these are your standard flame detectors, your Honeywell ones or Hikvision or whatever it may be out there. Again, these systems do not work until you've got a flame. They need the algorithm or the visual image of a flame to actually see a flame there. Once we've got a flame, with our experience with different MRF wastes, even in perfs, that flame moves rapidly. I was at a site in Scotland. I'm not going to say the site I was at, but we saw the start of a fire while the guys were getting the fire hoses to go out. It started off in a small area. Within 30 seconds, there was 20 square meters on fire. So you can see how rapidly a surface breached fire will actually go, irrelevant of what's actually going on inside the waste pile. And finally, obviously, sprinkler activation. At this stage here, you can see we've got huge fires. Again, the sprinklers will try and abate the fire from taking the building, but we all know that even with sprinklers, you can get steelwork damage, you can get building damage, roof damage. Then you've also then got obviously the smoke and the fire and everything leaving the building. Again, it's too late. It's uncontrolled thermal runaway leading to potential loss of building. Ewan actually quite rightly said there's a part of this slide missing. which we didn't add in, which is customers that haven't got any protection at all. And that goes straight to potential loss of building because they don't detect it, they can't suppress it. With ATFS, we can be right back here. We don't have the fire, we have the hotspot. Or even if it's a compromised lithium-ion battery, which has been hit by the blade of the loading shovel that creates an immediate fire, then we can deal with it. The camera system will see it and it will actually detect and put the fire out. So let's give you a better insight to technologies that are on the market, where they fit in the timeline of the fire development, on how big the fire can actually be before it actually takes action. So how does ATFS work? So ATFS is made up of a pump station with its own built-in water tank, with its own pumps. We generally have either diesel and electric pump or 2 electric pumps with diesel generator backup. We then have a targeted cannon or turret, and then our PyroSmart camera system. So this whole system is linked through our comms cable to a control center. We don't need anybody at the control center because the system is fully automatic. But for a visual screen where we have pre-alarms and the client wants to see what's going on, they can go back to that screen and see what that hotspot is. So normal daily operation. So we can see here, we can see the camera scanning the entire area. One camera can probably cover an area 100 meters square. One cannon can cover an area anywhere 50 meters in diameter. So I can throw water from any one position inside a building 50 meters. But that can obviously change dependent on the setup inside the building. So if we have push walls, if we have any fire breaks, if we have any areas that create blind spots, then we need more cameras, more cannons. But dependent on the size of the building, we should be able to get the camera and the cannon system up at height and minimize the amount of infrastructure required to protect that building. In most cases, in most MRFs, we have 2 cameras and 2 cannons. One that gives us it deletes any risk of blind spots generated by push walls or Lego block walls, but also it gives us overlay of protection of the system. So if we have an issue with a cannon, let's say a cannon was damaged for whatever reason, the other cannon would be able to take over. So we've got double overlay of protection on the system should one of the cannon or cameras actually fail. In the period that we've had these, we've never had that incident at the moment, but it's an inbuilt fail-safe into the system. So you can see here the system's scanning the entire area 360 degrees. The camera rotates 360 and scans the entire hall. The camera is looking at 78,000 pixels per second to ensure it actually sees any slight changes of temperature in the waste piles or in the bales or on the plant. It will look at those and it will then come back to us and tell us if there's any issues. So normal daily operation. We can see the camera scanning as we saw in the last slide, and let's say we've now got a hotspot that's developing inside this waste pile that we can see here. So the camera system will acknowledge that and it will see that temperature rise, but it's not a temperature that's going to give us our pre-alarm. In general MRF waste, we would be setting a pre-alarm at about 90 degrees. So anything that achieves 90 degrees by 50 millimeters by 50 millimeters, it will then obviously react. We're saying here now that the hotspot is below the trigger point, but it can still see that hotspot. It will then obviously monitor that for the duration until it sees any change in temperature. So stage 1 pre-alarm now triggered. So that hotspot that we had in the last slide has now, in this case, it's hit a pre-alarm of 50 degrees. So that 50 degree heat has hit 50 degrees at 50 millimeters by 50 millimeters. That then gives us the warning back to the control center to say there's an issue. We're not going to activate the cannon. We're not going to go off on the waste pile. We're giving the client the opportunity now to go to the video system with built into the camera to actually zoom in to see what that problem is. If we see a little bit of smoke or we actually see a small flame or something actually going on there, then the client can actually press the button on the screen to activate the system immediately, even though we've only hit the hotspot trigger point of, in this case, 50 degrees. In most cases on MRFs, we do 90 and 150. So here now we've given the client the opportunity to check. If in that case, it might just be a piece of hot material that's come off a shredder, we can forget it, take that piece of hot material away, we carry on. If for whatever reason we then get escalation in temperature, and we then hit 150 degrees at 50 millimeters by 50 millimeters, the camera system will actually then send the coordinates to the cannon system and to the pump station to react. And this happens within seconds. So we have to give a 30-second evacuation time for the site, so to get plant and machinery out of the building, more importantly get operatives and all the employees that are working in that area out of the building before we activate the cannon system. What we don't want to be doing is activating the cannon on a person that's walking through the fire exit. So in this case, we detect it, we send the signal to the camera system and cannon. The cannon system then activates the alarms, and 30 seconds later, we are then activating the targeted suppression. So what happens with the suppression system is the camera system will say, I have found a hotspot at this coordinate. It then moves the cannon to that area, and we can hit that area within 50 millimeters accuracy of that hotspot. Outside of that, then potentially, if we get any other ignition sources coming out, so let's say an aerosol was then to explode, what we don't want to do then is have the waste pile having multiple fires. So the system itself is programmed to hit the hotspot first and then spray a 5-meter area around. The additive that we're spraying that's coming out of the pump station has a wetting agent included in it through our proportioning system at 3%, which then turns the water into a surfactant and a retardant. So anything that water touches won't set fire. So the potential of fire spread then is minimized through the additive that we're spraying. Outside of this, which isn't actually in the presentation, we can actually take manual control of a fire as well. So if the fire brigade were to turn up and the system was still going off, which we already know through the stats that you saw before, we don't go off for more than 3 minutes. It's going to take the fire brigade between 8 and 12 minutes to get to site, dependent on where they are, and the fire will be out. But let's say the fire brigade turned up and they wanted to be using the system rather than the camera system. Why? We don't know, but they do like to actually have control of the cannon systems in cases. We have a remote control outside the door that's in clear view sight of both the camera and the cannon. We supply the camera system with a tablet that the incident officer can have in front of him. He can see any hotspots that might be building in the waste pile, and he can manually take control. But from our point is, well, why would a human want to take control when the camera system, the thermographics will see it quicker than the fire officer, and he'll be able to deal with it a lot quicker than than human intervention. So once we've had the activation, 3 minutes have gone by, the system automatically shuts down. Again, nobody's got involved with it at this point. The camera then results back to going back to its normal operation of day-to-day scanning of the area and ensuring that we haven't got any reignition of fire within the pile. What actually happens inside the pump station is we're not allowed to turn this pump off here. So even though the fire's out, we've now closed the valve here in the pump station, but the water is still circulating through the system. We're not allowed by NFPA and LPCB rules to actually switch this fire pump off. That is down to the client to actually have to do. And part of the SOP is, let's say this happened at 2 o'clock in the morning and there was nobody there. The first operative who goes to site will go to the screen first. Is that fire out? Yes, that fire's out. Okay. Is there any other hotspots that I can see? No, there's not. He will then make his way to the pump station and then switch the pump off. He then doesn't need, we don't need this pump running for any longer than it needs to. So we're not running against deadhead. We actually run the water back through the test loop to ensure that we're circulating the water between the water tank. But if a fire was to start again up here, then the pump system would automatically fire up and start fighting the fire again. So infrastructure-wise, so go into what the system looks like, how it's installed, what it looks like inside the building. We've changed a lot of the infrastructure now for the installs. These boxes now we don't install inside the building anymore. This is the only box. So for the camera, and the network box stay inside the building. It's all fireproof cables, but any communication boxes now for any of the system are all outside the building to safeguard should there be any incident that the system didn't deal with, or a huge explosion or whatever else. So inside the building, we have the PyroSmart camera. It has its own calibration system. So every time that it sees a hotspot, it will then self-calibrate. It will check, and this goes back to the question we had before about looking for vehicles. Yes, within the database, it knows about vehicles, but it will also then recheck the calibration to its temperature. There's a hot plate inside here that is set at a calibrated temperature. The system always calibrates back to. We have compressed air. So coming onto the system here, we have compressed air that comes through that flushes the main PC up the arm and then onto both lenses. So the system is fully maintenance free. We don't need anybody going up to the camera system to wipe the lenses. We can work in very, very high moisture environments, in very, very dusty environments, without having to maintain the camera. Yes, we maintain it. We come out twice a year to check it. We also then get warnings from the camera to say, yes, I've got some dust buildup, you need to clean me. It will tell us that, and we then obviously send an engineer to do it. We don't expect the client to have to go and do it. So we have the camera and Canon side by side. So some more images. So going back to what we said before, we've got larger areas that we can cover with this camera system because of the ability to be able to rotate. So this camera in this position here will be able to rotate full 180 degrees that way and that way. In most cases, if we put the camera system upside down, we can do a full 360 of an area, and this camera system will move up or down at an inclination of 120 degrees in either way. Again, you can see quite clearly here the cabling and the compressed air already connected to this camera system, and you can see the area that we're protecting through this image here. So a bit of a quiz for you. This image is an image from one of our client sites in the northeast of England. It's a big site. It's got 5 cameras, as we can see here. This is the old software. I'm going to show you some of the new software in a minute. But this basically shows the 5 cameras that they've got, and they rotate like a CCTV camera system. They roll through. This camera here is looking at this entire area from this side of the site to this side of the site, which is 400 meters. So the viewpoint of the camera is very, very large, especially in open plan areas where we want to look at open yards such as this. The only downside to larger areas are the fire or hotspot has to be bigger at the extremities away from where the fire is. So if we had a hotspot here, a 50mm size is at 50 millimeters, but that 50 millimeters over here may have to be half a meter before we'll actually detect it because of the distance away. Not a great deal we can do about that apart from putting more cameras in. This client had already installed 5. He has another camera over here, another camera on this post here, another camera here, and another one over the back on this side. So we're able to have multiple cameras checking over each of the waste piles. So you can see here we've got a large waste pile here. There's another one going, will normally come all the way down here. There's a big runway on the back here that has exactly the same windrows of wood waste, which causes a big problem for us because I can't see the other side of this waste pile, hence the reason why we have multiple cameras looking across each other to get overlay. But going back to the slide before, we've actually stated on here, spot the fire. Well, we'll run through some of the data we're actually getting. So this crosshair here is telling us our hotspot on that whole screen. That is the hottest part on the whole part of this image. But it's also telling us that hotspot is 65 degrees. So we're nowhere near a pre-alarm or a full alarm, but it's telling us that we've got a temperature there and it's there. But there is actually a fire going on this screen. So it's very difficult to spot a deep-seated fire with the naked eye, but with advanced thermographics, we can detect these fires very, very early before they breach and have thermal runaway. So the next slide now, you're going to be able to see the thermographic image of that video image that you've just seen there. So again, the trained eye could probably, some of you guys might be experienced enough to look at a thermographic image and look at it, but there is definitely a fire on there, and the fire is here. So we can see here we've got the hotspot showing through on the waste pile. You can see the rest of it's all purple, but we're still only showing 58 degrees, and our hotspot now is on the back end of this loading shuttle. So again, this temperature here will have been probably somewhere in the region of 30 degrees, but the rest of it will have been 10 or 12 degrees. So we're seeing very, very early the potential of a fire. There is actually a secondary fire that actually had to be dealt with on the site, and that's here. You see this band running through the centre of this waste pile. Well, this waste pile had been taken off the top and it snowed. It snowed on the top, and then they laid new, fresh, warmer material onto the top, which created a very, very warm, damp environment, and we had an organic fire actually starting, warming up through the centre here. Yes, it was only 17 degrees, 18 degrees, but it was warmer than the rest of it, and this would have caused a fire had it been not had the thermographic detection to actually see what's actually going on. What you can see here, we're up at temperature, we are warm, we are looking at the hot spots, and it's telling us our hotspot is that loading shovel, but again, it's not causing us an issue. We don't have any alarms. So we've now developed over the past 4 years the software, so we don't have to have two screens. We shouldn't have to flick between video and thermographics. So we've now mixed the two technologies together with an option to be able to move from full video right the way through to full IR. So this image here is showing a waste processing plant with a 50-50 image. So it's 50% IR, so we can see heat signatures, but it's also giving us the full 3D and video effect of the PyroSmart camera and of that area through the video camera. So we can quite clearly see the movement of vehicles inside. We can see what's actually going on, and we can see our waste piles. Wherever I was to move my mouse on the screen like this, I could see the temperature of every single pixel in that area. So this is that same image with the vehicles gone now, the vehicles left the building, which was here. So we can quite clearly see we've got 4K full high resolution images. We can stop the camera system from looking and actually zoom into particular areas. This box here is where the camera is live now. So you will see here we have the screen made up of 1, 2, 3, 4, 5 scans. So that screen is made up of 5 or 6 bands, and inside those bands are the image and the temperatures for those images. So again, going back to what we said before, we have our hotspot. So this is our new trigger point, which is 17 degrees. But also now we're able to tell the temperature of the ambient temperature inside that building, so we don't get false alarms based on temperature drop. So let's say in Scotland, we've got a client, Hamilton Waste at Musselburgh. They have a system installed, and it went from 18 degrees in the daytime to -6 in the evening, which is a big fluctuation for a thermographic camera. If it doesn't know the temperature sat around it, it can't understand what the true temperatures are inside that building. So our system can actually know the temperature that's sat around it as an ambient average temperature and for the building itself, and then it recalibrates itself to understand the heat sources inside this building, whether it's inside these bays, whether it's over here inside the plant, or it's inside the actual storage bays here. So that same image, but in thermographic. Again, going back to what we said before about seeing the images and looking at thermographics and understanding what thermographics look like, you can see here we're at 100% thermographic. So outside it's dark, it's cold. That's because it's cold outside. We've got grayer temperatures on the floor because they're cooler, but then we've got this massive glowing area. But again, it's only 17 degrees. It's warmer material, but it's not alarming. It's telling us that's the warmest part of the building. Freshly produced material. Ambient temperature in the background is 9 degrees. We can pick up in the background, you can see all the glowing hotspots of motors and conveyor belts and stuff in the background. Again, we're not going to go off on those because we've isolated them, but the temperature isn't high enough for us to go off anyway. So if we were to hit 90 degrees on that pile, then the camera system will then go into pre-alarm, and then it should hit 150 degrees. It then goes into the full extinguish and the cannon system goes off. Infrastructure. Again, I'm going to just scan over this very quickly. We have camera systems that come through through a junction box that converts to fiber optic. Fiber optic we need because of the amount of data. We're taking a terabyte a week per camera of data from the site to the network box and to the camera system that people are going to look at. I would say 80% of our clients, nobody even looks at the screen. They only look at the screen when they've got a pre-alarm or a full alarm. It sits on a wall in the plant control room or in the one of the director's offices or a main office where somebody's walking by all the time and they can have a look. But we can put multiple screens on. We just say to people, leave it alone. Let the system do its job. If it alarms, go and do something about it. The system's then obviously linked directly through to our ATFS control center in the pump stations, which has got its own control center inside that sends the coordinates out to the Canon system and then remote controls. So what does the system look like? You can see here, this is a hangar that we install one of our systems. That's a 90-meter throw area that we've got on the Canon system, and they're all different dependent on the size of the risk that we're looking at and how far we want to be able to throw water. This is an aircraft hangar that we did with ATFS. So we can go from 0 right the way up to 100 meters, and we can go from 100 liters to 3,900 liters a minute. The camera system, again, going back to the intelligence part and the AI and the learning, when we are programming the location of the camera in the Canon, it's also intelligent enough to know how far away each of the incidents are away from the camera or the Canon. So we wouldn't want to be hitting a waste pile 5 meters away from our Canon with that sort of hit, because we're going to spread the fire, we're going to spread embers, we're going to have a bigger issue. So the camera system tells the Canon how to actually tackle the fire. Do I need to go on to a wide, large open spray, or do I need to hit it with a full stream jet like we've got here? And again, the camera system will tell the camera, the camera system will tell the Canon how to actually go and deal with the fire in that incident. So I've got another short video here. There is no sound to this one. It's just showing the Canon system in a perf. So you can see here, obviously the Canon system's moving into position. The camera system's checking its calibration to ensure that it's working properly. The system's gone into full alarm, and now it's sending the Canon to the position of where the fire is. So in this case, it's not actually a real fire. We've set a red wheelie bin up in position, and we have to hit that target area. So we can target that area very, very effectively. And then in this case, we sprayed a 2-meter area around. The camera system is now checking for any further hotspots. Is that hotspot been dealt with? Has it dealt with that fire? Yes, it has. It now automatically goes into shutdown. Meanwhile, the camera is scanning the rest of the building for any other fires elsewhere inside that building. So should it see another fire, it will then move the Canon to the position of that fire. So camera's happy, fire's out, the system stops, and the system drains down. So we can quite clearly see here on these slides, you can see how the system can actually go from that large spray that you just seen inside that video to actually a misting spray here. So we can actually cover a larger area should we need to, but also not to actually disturb any of the waste pile and spread the potential of the fire. So some install images of ATFS. Just so you can see, get an understanding from us, our professionalism, how our projects look, the infrastructure that is installed inside the buildings when we're installing it here. So this is for Envar at Colic. This is a 5 Canon system in a 40-foot container with water tank. So again, we install this, the concrete pad, the container, all the pipe work. It's a full turnkey project. We supply and install everything. The only things we ask for the client to provide are power and a water supply to the tank and an internet connection. So you can see inside they're all nicely, neatly laid out and set. So the engineering teams on side can quite easily do their weekly maintenance checks and keep the system operational. Another one for Envar Colic. So again, you can see from the different side, obviously the cameras and the Canons looking the opposite way down. We have our diesel engine in this one and electric. and then you can see the quality of the pipe work and how it looks once it's inside the system, and then a system going into full activation. Biffa at Teesside, at their perf. Again, this system here, the client only wanted one pump. We design the systems to requirements for each client. Whatever their insurer wants, we can provide. If they want one pump, they want two pumps, they want diesel generator backup, we can supply that. Our cannon system, we can alternate the flow. No other cannon system on the market can do this. We can actually send it from 500 litres to 3,000 litres a minute through the same cannon. We just alternate on this regulator here to actually give us the flow that we require for that particular area. F&R Corley at Luton, again, just showing the technology and the engineering that we install into the systems. London Energy, or the old Seneca site. Alan Morris, big paper recycler. Lancashire Waste Recycling, again, another big client. He has 4 sites that we protect all of his sites. Viridor Crayford, largest MRF in Europe. They have 10 cannons on this site with diesel and electric pump systems, and we're protecting all their input halls and processing RGS sites. So some of our clients, our biggest client is Biffa. We're preferred supplier for Biffa. For every single MRF, we're currently in process now of installing probably over we've got 18 sites to do for DRS, and then we've got all their other larger MRFs and stuff down in England. Envar, we've got 6 sites. Viridor, we've got 5. Hamilton up in Scotland, we've got their large site at Musselburgh. Surico or Refsol, Dumfries Council, and you see the rest of it there. We've got systems on all these sites, ATFS cannon systems. We're one of the only suppliers in the market that can have recommendations. So I'd say endorsements, but they're not allowed to endorse. So our systems now are fully recognised by all these insurers, and any clients that have these systems, when these guys come to look at a potential of taking that risk on board, it's pretty much a tick in the box because they're recognised through their fire engineering teams as one of the best systems on the market. And finally, that's the end of ATFS. I hope that's given you a good understanding of the system and how it works, and how advanced our technology is in being able to target fires. But more interestingly is to actually detect it before it becomes a fire. That's the big issue. Helios Fire Systems are experts in targeted fire suppression systems. Early warning, nobody else can do that. There are other cannon systems out there, but they spray huge zones, they spray large areas, but they only go off IR3 detectors. Again, going back to our slide before about different technologies, our system is way in advance of anything else that's on the market to stop the sites having these issues. So I'll open the floor up to questions before we move on.
Anyone have any questions at the moment? Or I have a few.
I've got one. If I can dive in first, then.
Yeah, fire away.
So, Simon Norris, I'm operations manager of MVV in Dundee. So we run three lines. One site uses RDF, one site uses MSW. Our RDF site is an aging one, so we've got an existing sprinkler system, stuff like that, and quite an extensive fire suppression system. Would you be able to incorporate your cannons into our existing system, or would you say no? We have to have the whole lot, the tank, the pumps, everything.
You don't have to have the tank. Obviously, from a liability point of view, our insurers won't allow us to use anybody else's pump station or infrastructure. Right. But that can be on a case for case basis. We have done one where we've used the client's existing sprinkler system, but the big issue with that is you have to get permission from your insurer. Because obviously from an LPCB and NFPA point of view, you're not supposed to be utilising the water from a sprinkler system for, or taking the demand away from that water supply or pump system, even though the cannon system will work a lot quicker than the sprinkler system, way in advance, and you will never use your sprinkler system again. It would have to be a process where you would have to approach your insurer and say, look, we're going to make that a secondary system and it's really going to be redundant, but we're going to then install this system utilising our pumps for the cannon system. So really all we would have to do is install our control equipment into your existing pump station. It's a pain, it's a lot of more work, and it's a lot more time to actually deliver. But yes, it can be done. We've done it once, but in most cases, the client says, well, you know what, if it's going to take X amount of weeks to go and do for the cost of the pump station, I've got an area there for it, utilise my existing water tank and put your own pump station in. And then from a liability point of view then, because if there's a fire and your pumps don't work, we'll just turn around and say, well, your pumps didn't work. Pumps didn't activate.
No, makes sense.
So obviously from that point of view, we've just got to be very careful and ensure that we that we cover all liabilities. But it's not a no, yet we can do it. We prefer not to, and we work on each client on a client-for-client basis, really.
Okay, thanks for that.
So another question, I hope I pronounced your name right. Is it Tyrene Rutherford? You want to ask your question?
Yeah, it's Tyrone, close enough.
Tyrene, sorry, apologies.
No, don't worry about it. I've been called worse. I'm from Suez in Aberdeen. So my question was regarding the servicing. So is it yourselves that carry out the servicing?
Yeah, we've got a team.
Or get a subcontractor?
No. We do it all ourselves. We've got a team up in Scotland, based in Dundee. And they cover the whole of Scotland. It's a new team. We've just set Helios Scotland up based on the amount of work we've got in Scotland at the moment. But obviously with this new DRS contract that's kicking in, we have to support all the systems up there. So we've opened an office up there that's got its own team, electricians, service and management team.
No problem. Thank you.
Okay.
Can I ask you, Gary, from get an initial contact, go on site, previously people would probably think about the type of material on the site, the dangers of those materials, where they're located, then where you might get a fire from, so self-heating, electrical faults, moving plant, where you get friction. I take it you go around, you do a site survey, identify where those risks may be or high risk areas, and then come forward with a proposal for the layout of your system. And I'm assuming that not all of your clients are perfect, and when you look at some of the sites you think, I am astounded by why they put that material next to that material. You can't see around here, or nobody ever goes there. What's the time frame from the survey to the offer, and how far do you go in terms of saying really part of the issue is the layout of your site and how you store material?
Yeah, again, we can give advice, but we're not here to advise a waste operator on how he should be holding his waste. All we're here for is to look at the risk and then design a system best to cover that risk, even in the current situation. It might not be ideal, but they might not have an opportunity to be able to change that. They might, if they've got multiple Lego block bays, which creates lots of blind spots. They just need more cameras, and that's all it is. And again, each site is designed bespoke for that site. To answer your question on time, if we were to get an inquiry on Monday next week, we would be out during that week to go and do the survey if the client needed it. Generally within the following week, you'll have a full system design and full system cost. From there, if the negotiations go right and the client says, yes, I'm happy and I want to press the button, I want to go. Currently, with our current workload, it's about 14 to 20 weeks lead time for installation. Purely down to the fact of how many systems we've got to install. I've got to install 18 systems between now and August next year. But we are taking more and more people on. Scotland isn't as busy as that, and we have extra over capacity there to go and do that. But the lead time to build systems is about 14 weeks.
And what about following on from that point? I mean, there's people having problems getting parts for kit, spare parts for kit. I take it you've got stock or direct access, or do you have any issues in that area at the moment?
That's the reason why we're at 14 weeks. That's our longest lead time. Well, our longest lead time is 12 weeks. So it gives us a 2-week final build and commissioning on site, not customer site, but at our factory before we send it out. So yeah, we've got forward orders. It's more electronics we're struggling with rather than metal and hard infrastructure. It's more chips and boards for the alarm systems that are creating us problems. Yeah,
so
we've got
Gordon from Lomac has a question. So,
okay,
do you want to ask your question, Gordon? I may have frightened you and got you to mute yourself permanently, but do you want to give it another shot? Hello, Gordon.
Can you hear me now, Duncan?
Ah, yeah, we can hear you.
Yeah, no bother. Thanks for that. Thanks, Gary, for that presentation too. It's interesting to see how far it's come for. I spent a lot of time looking into trying to source even something that would detect a fire in a waste site, worrying about the dust and whatever else we have to deal with. It was infrared at that time. So 2 questions really, Gary. The first one's probably a length of a piece of string. Cost obviously is a big thing that faces everybody, but if you were to look at a single cannon, for example,
yep,
system with automated identification.
So a single cannon system, obviously you need 1 cannon, 1 camera, 1 pump station, 1 water tank. You're looking at an entry level price. Obviously, with this includes all the mechanical and electrical, because it is a full turnkey project we do. We don't expect you to deliver anything. The only parts that we ask you to provide are power, water, and internet connection. And the water supply is just like a normal 50mm connection. We're not asking for a great big 4-inch main to come to us. We've got enough capacity in our water tanks to give an hour's worth of firefighting capability with no infill. So for that sort of system, you look at an entry level of about 350,000 for a 1 cannon system. But then to go upwards to that to 2, 3, 4 doesn't go up by another 300k. It goes up by another 60k. So the subsequent cameras and cannons after that then all come down in price. As we go along, the main cost is in the main infrastructure, in the concrete pads, the water tanks, the pump station, and then obviously the tech. But once you've bought the tech, then the price comes down afterwards.
Does it have to go via a tank, Gary, or can you come direct to hydrants? Are you not allowed to do that?
You're not allowed to. Well, it doesn't bother me. It doesn't bother me. The only, again, going back to the other question before, it's about the liability of supply. Yeah. So if that water supply fails, or let's say there's a fire further down the street and the fire brigade are putting a fire out down there, and you have a fire on your site and it limits me less than 1,500 litres a minute and I can only get 800 litres a minute out of it, then it causes a big problem.
Yeah, great, thanks.
And I take it you basically want to maintain that relationship with the operator during the period of the life of that company. So if the site's redeveloped, you'll go back in and look at, can you move stuff around?
Yeah.
You need a different layout.
And it's totally modular. You can bolt on, you can add kit on, you can move stuff about once it's in it. Once the survey's been done, it isn't fixed and final. If it is for that first incident, in 2 years' time, we've got a client at the moment that's ripping all this plant out, Grangemouth, and putting it in another position. So we're going to have to move the cannons and the cameras, which isn't a problem. The infrastructure is already there. It's just a matter of fact of rerouting it. It's just a mechanical and electrical install again. That's it.
I take it you do, like, if there's upgrades to the system, the technology, I mean, it looks like it's pretty accurate stuff anyway, and it's at the cutting edge. But if it does upgrade or software upgrades, I take it you do that as part of this as well.
Yeah, for the first 5 years, they get free software upgrades to whatever the next update is. After that, then it's chargeable as they move forward. But it's not ridiculous. It's not like saying, well, we want another 50 grand for the new software. It might be 7 or 8k. Well, that's in 5 years' time. But you know what? The technology yes, it's moving. We've got some new developments that we're working on with the system at the moment to make it even more accurate, and even more accurate in its understanding of the data that it's dragging in. We're working on databases that we can offer clients to understand temperature fluctuations in different seasons, in different stock holdings. Are we seeing any temperature increases because a product's being stored in a certain way? And again, these are all things that we can offer as add-ons at a later stage if a client wants to understand.
Is that because do you gather all that information
Yes.
centrally from every site that you've got
Yes.
kit out in? So you have a background image of a large amount of operational sites in our sector right across the UK at all parts of the year and seasons and parts of the day.
Yes, I've got all the data.
Okay.
But
I'm gonna suggest we stop there because I know that I think it was control panels in cabinet protection you're going to talk about next, and I'm keen to let
this is
you
going to be a
do
very, very quick. It's a very, very quick one. The next one. It's literally a 5 minute.
I'll switch off, disappear, and let you do that, and then come back again.
Okay. Right, so the next presentation, it's nowhere near as long as the last one. The next presentation is our AMFE, which is in cabinet fire protection systems. Again, it's another large area where we've seen huge increases in the risk of fire. And obviously, once these cabinets are closed, nobody goes near them, and they end up getting full of dust and components breaking down and yada, yada, yada. And there's lots of systems out there for in-cabinet fire protection systems. But from my point of view, they were all very, very expensive. And it was really more about trying to find a solution that could be retrofitted, be as accurate as a lot of these pipe systems that could be installed, but at a tenth of the cost. And that's the important part. It's about the cost. Yes, we have ATFS, which is an expensive piece of equipment, but it does its job. It's high end and whatever else. This is a high end piece of technology that we're putting inside these cabinets, but the cost is a fraction of that of what's available on the market. So I'm just going to share this this slideshow with you now. Okay, so AMFE is an acronym for Resistance Automatic Miniature Fire Extinguishing System. What we can see here on the screen is these are small cylinders, and they go from the largest cylinder being about 12 inches tall and probably about 2.5 inches in diameter to protect something of this size. Let's say that would be a 1500 cabinet by 2 meter. That one cylinder will protect the area, but we'll go more into that in a second. But we came across this product about 4 or 5 years ago as a potential bolt-on system that doesn't need a lot of infrastructure to run. We don't need to bolt these to alarm systems if we don't want to. They can be retrofitted inside electrical control cabinets very, very easily by site or by our engineers. But I'll go into what the systems are. There's a short video. There's a short video here. I'm gonna have to talk over it again. I don't know if you can just let me know if you can hear the audio on this one. It'd be great. If not, I'll just talk you through what's actually going on.
So here, no audio at the moment.
There's no audio, right? Okay, so I'll talk what's actually going on. Again, when we send the pack out, you'll be able to play these videos and you'll hear what's actually going on. But I'll do my best to explain what's actually going on. So we've got our AMFE here now. Obviously, this is an in-cabinet protection system. So basically what we're explaining here is obviously you have multiple control panels. It could be in an in-plant area. We're protecting it here with the cylinders that you can see on top of each of the cabinets. These can be installed inside or out. We have another system called E-Detect, which is an early warning capsule, which can give us a warning of an overheating component. If that component goes into thermal runaway, we then have the AMFE cylinder that's then automatically detecting smoke inside the cabinet. So should the AMFE system detect smoke inside, as you're going to see now, we have the smoke coming from the component. The detector here detects it, and then the AMFE system then deluges in that area. So it has the additive that's coming out of that system is a Novec 1230, which is a non-conductive, non-corrosive product. It has no negative impact on any of the components. If you've got PLCs inside there, if you've got any other high value switches and equipment, then this system will not damage those in an event of a fire. Obviously, if it gets caught by whatever the incident is inside that cabinet, then the system, obviously they'll get damaged by the flames until the system goes off. So going on again to what the system is and how it works. This site should have had AMFE. It should have had some form of fire detection inside its control panels. Inside here on this top floor here was all robots, and the control panels for these robots overheated, had some issues and set fire, and they lost the whole building. I think on the next slide it goes into some details. This was a £120 million site, and it was brought down by 2 controllers inside a control panel which failed. They had no detection inside there, and it went from one cabinet to the next to the next to the next. So it caused them huge problems, and obviously they lost the whole building. So AMFE is built up of a cylinder. These come pre-filled. They're sacrificial, so once they've gone off, we don't refill them again. They basically go in to be recycled. The cost to actually send them back to have them recapped and repressure tested and just puts the price through the roof, and it's just not worthwhile. So they are sacrificial. Once they've been discharged, they go. We can see here, this is the nozzle. Inside this nozzle here, we have a sprinkler bulb, and these are set either 68 degrees or 93 degrees, or in the case of where we're using our AMFE, it has a metal coating painted onto it, and these contactors here and here are connected to a relay-based smoke detector. That relay-based smoke detector, upon it detecting smoke in the area, sends a 9-volt signal through the contactors, which then goes across the bulb, shatters the bulb, and then discharges the system. Again, you'll see that as we go through the presentation. So there's the different types of bulbs. We've got the standard one, which goes off on heat. We've then got nickel plated for going into food industry. We've then got the RAMFE, which is the resistant bulb. And you can see a closer image of that there, the 2 side by side, standard, and then the one with the electrical connectors. The client doesn't need to have it going off by a smoke detector. They could just utilize these as an open closed circuit to tell the client that the system's actually gone off, and they don't even know they've got an issue until the system actually alarms and goes into fault. So a selection of some of the nozzles and the cylinders that we provide. So when we're actually installing, so this would be a typical installation. So when we do this for a client, we take all the client's cabinets, we do a full design for them to show the areas, take the full volume. We have to work the volume of the area out, even if there are no compartmentalization between cabinets. So we can work out what volume is in this cylinder that will protect that entire area from a potential fire. So stage 2. So what we're looking at here is normally we're looking at the system is detecting all the time. Upon detection of a fire inside, and let's say it's worst case scenario at the bottom part of the cabinet, the smoke detector will alert. It automatically sends through the signal through to the alarm, which then sends an SMS out to say there's obviously an issue, or to a monitoring station, sets the site alarms off. Here, so we have the SMS, and then we have site alarms, and then secondary, it then sends the signal off to the system to deluge. So once we have the signal for deluge, the bulb shatters, the contents come out of the cylinder. The liquid at 40 degrees then becomes a gas. It's a non-toxic gas. It's not, there's no issues. It's not like FM200 or any other gas that would mean operatives need to leave the building or get away from the vapor. You can sit by it, you can breathe it. It's not toxic in any way. So once the system's actually done its job, the fire's out, so we can see the bulb's gone. Yes, we've got some damaged components down here, but you've protected the system from fire spray. So infrastructure basically is we have an alarm panel, siren, beacon. We then have the power signal going through to the detector. The detector then sends a signal to the AMFE to actually discharge. And you have one of these for each and every cabinet as you go along. To give you a rough idea on price, a one cabinet system would be, including the alarm panel and everything else, probably about £560. Whereas if you were looking at a fire trace system or Reacton or any of these other systems that are out there, if you were doing these, you're looking at about £1,500 or more per cabinet, and then you have to have multiples. With this, if you only got one cabinet, it's one at £500. If you've got multiples, that price comes down because you've already got your alarm panel, so your next one might be £400, and then it goes down, down, down from there. Some installation images, so you can see how we've actually fitted them. So you can see we've got our detector, you can see the cylinder here, the alarm panel, sounders and beacons, and then obviously inside these cabinets, if they do have a fire, we'll either detect it through the heat, or in this case, obviously we'll get the early warning with the detection through the smoke, which will then automatically discharge the system. That's it. Nice, quick, simple one. Very, very simple technology. Probably the most advanced on the market again. But from a price point of view, it's becoming more and more viable to a lot of customers who don't want to spend £1,500 per cabinet. They can reduce that by 2/3 and have a system that will do exactly the same with a cleaner agent. We're not using powders, we're not using FM200s, we're not using nasties in there to put the fire out. And the great thing is it doesn't damage the components afterwards. So open floor, guys. Ask any questions. If you've got any questions about the system, then shout up.
Does anyone have any questions from what you just heard there about control panels or anything you've heard previously? I have one last question, wait and see whether anyone puts anything in, but in terms of that maintenance program for the on-site staff, is that a weekly, fortnightly? How does that work? And obviously, in terms of installing the cameras and the pipe work and other bits and pieces with a lot of trucks going in and out in case of banging stuff, does it have a kind of system that says there's something wrong with me? I'm not reporting properly. This has been hit. Do you have anything like that?
Yeah, the system's fully fault monitored. So if a cannon gets hit or a camera gets hit, going back to the ATFS system, then that is fully alerted back to us and to you as the client. So you'll get a text alert. The system will go into fault. The screens will show that there's an issue and we'll deal with it. Our SLA, we have 3 levels within our service level agreement. Any issues with the system that is green or we class as green, which might be a software glitch. It might be something on the screen that's causing a bit of a pain, but it's not a massive issue. It's just more of a hindrance to the client. We have 72 hours to resolve that one. We have amber, which means it's an issue that is not stopping extinguishing or detection, but is causing faults or alarms on the panel. We have 24 hours to resolve that system. And then we have red, which means anytime the system is down from suppression or detection, we have 12 hours to get to site to get the system back up and operational. With regards to your question about installation, on most installations, we're doing it while the plant is fully operational. Obviously, we can't work over plant and they'll be done out of hours, but most of the time we work with the client to actually install the system. A lot of the time, the pipe work and cabling runs around the perimeter of the building, so we're not cutting across any major areas, and we know that we can't get around the perimeter at all points. So our operations team work with the clients at the project management stage to say we're going to be in this area tomorrow, and then Max will say, no, you can't do that tomorrow. We've got 20 wagons coming in tomorrow and we're going to be processing all day. So that's where we will then plan to do evening work, weekend work, or whatever we need to do to get across that area. But I would say 80% of the install is done while the client's operational, and we have no operational downtime.
Training and handover, how long do you do that for?
2 days.
Okay.
maximum 2 days. But if the client then, as we know, the waste industry, they go through a lot of staff. Staff move on and move places. We don't charge to come back to site to go and do another day's refresher training, or we've got 3 new site supervisors. Can you train them up for us? Yeah, fine, not a problem. We'll come to site, go and wander through it and just check everything over. Obviously, we ask for 1 person on every shift to be responsible for the cannon system. So if there are any faults, or if there are any activations, or there are anything needs to be dealt with, there is somebody on every shift that knows what to do. There is somebody on every shift that knows how to do the maintenance, and the maintenance isn't long by any stretch. We ask on the cannon system that they run the pump system for 15 minutes once a week. That's through the test return line through the pump system back to the tank. So not going to the cannons, just goes basically through the loop. And then we would say once a quarter they actually go to the cannons with a remote control, use a remote control, fire water with a remote control in a controlled method, so they know that everything's working. So
you're actually putting in place their maintenance checks and things that they should be thinking about doing anyway. So
there's a full checklist they have to do on a weekly basis.
So I have one final question, open-ended. Human error in amongst things can quite often be the biggest factor, and I know that what your system appears to have tried to do is remove as much of that hard thinking and say, this is where the issue is, that's what you need to look at, and this is the level of problem it's at now, and the system starts dealing with it. A big chunk of it is keep the thing working, keep it clean, keep it in place, and keep it active, and don't mess around with it.
In a fire scenario, there is no human interaction. There should be no. The only time there should be a fire where we need human interaction is, let's say there's a fire outside an extinguishing zone that we've set up. Let's say it's outside the door. We're not interested in protecting outside the door. We're protecting the building. But let's say there's a fire. Let's say there's a bin wagon outside that's on fire, and they reverse it up to the door, but it's still not in the extinguished zone. So they can then go to the remote control and take control of it, and they can then tackle that fire. So that's the only time. Or it might be that a battery, there's been a load dumped outside the door because there's too much waste inside, and there's a battery fire on a pile outside the door. Because it's not in our extinguished zone, it might be the fact that the guys go to the remote control, bang, hit the button, control it, and then deal with the fire outside. That's the only time anybody should be getting involved with the system. And the only other time outside of that is to switch the system off once they've checked that there's no hot spots in the waste pile.
That's great. Well, Garry, thank you very much for the time you've taken to put a really impressive presentation together. And thank you to Helios for agreeing to do the talk. And thank you to Ewan Monroe from SLR Consulting, who kind of championed the idea of getting you on and saying, can you let these guys have a platform to speak about their system, the dangers of fires and what you do. So thank you very much for that. In usual form, we will, with permission of Helios, post the webinar recording onto the website, and we will put contact details there if and when appropriate. I have one kind of advert for Switch Forum, which is we do quite a lot of work to try and ensure we've got at least one of these webinars each month. Another important issue that we need to consider in our industry is the potential to unwittingly come up against modern slavery. After being trained on this and seeing people who had been involved in modern slavery and how they got involved is a big issue, and everyone should be aware of it. Some of you are legally obliged, if you're a big old company, to have a statement as to what you do, and I know a number of you have done this voluntarily. But if you would like to hear more about that, you think that our colleagues should know more about it and be involved, we will have on the 27th of October a webinar on that subject, and I would ask you to see if you could attend that or persuade some of your colleagues, associates in your network to come along to it. But finally, Garry, on behalf of everyone, thanks again to yourself and everyone at Helios. And I'm sure we'll see more of you as DRS rolls out, running around the countryside. Great to know you have a site in Dundee, and we will post the information, and I'll maybe see if between us we can put a short piece together on content and agree that and post it alongside it. But thank you to all for taking part. Look forward to seeing you at the next Switch event, and thank you again for your attendance. Thanks very much, and goodbye everyone. Enjoy the rest of your day.
Thank you, everybody. Thanks for all your time. I really appreciate your the opportunity and for listening and not getting bored and dialing out.
Thank you.
Thanks very much. See you soon.